Hello everyone and welcome back. I'm Absissa and I'm here to help you solve exponential equations. Before we jump into exponential equations, we're going to go over their different parts and then we'll also go over the different parts of a logarithm. Just quickly touch base because we will be needing to convert the exponential equations into logarithm form by the end for the more complicated questions. It's not too bad. Let's just jump in. Parts of an exponential equation. Exponential equations are made up of terms that consist of a base and an exponent. An exponent is a quantity representing the power to which a given number or expression is to be raised. A base is a number that is raised to a power. Or, if you want to get a little bit more specific, a base is a number multiplied by itself as many times as indicated by the exponent. Moving swiftly along, parts of a logarithm. The base is the small number right next to the logarithm that is usually understood to be e or 10, though it can be something else. It is the number that is raised to an exponent or power in order to achieve the argument. The coefficient or multiplier is the number in front of the logarithm. With that quick refresher out of the way, we can now jump into problem 1. In the simplest of terms, an exponential equation is an equation where the x, or the variable factor that we're trying to find, is stuck in the exponent or exponents. Our main goal when we're given an exponential equation is to find a way to make the bases of the terms within the equation the same. That way, we can set the exponents equal under the basis of the one-to-one property. With that said, you can probably guess what step 1 is. Obtain like bases. This equation is pretty simple. All we have to do is rewrite 343 as 7 to the power of 3. By doing so, you can see that now both of our bases are 7. This allows us to set both of their exponents equal to each other. Now I feel so comforted to see my beautiful linear equation pop out of the muck of the exponential equation. And we can simply subtract 2 from both sides and we have x alone. And the answer here is 1. We did all that for 1. Yeah. Okay, moving right along to problem 2. As you can see, it's a little bit more complicated than problem 1 as both of the terms have an exponent and neither of the bases are the same. This means we'll have to rewrite both 32 and 4. Both bases can be expressed as power of 2, making it very convenient for us. Of course, now that we've created new exponents, we're going to have to simplify the exponents of both terms, specifically using the power-to-power rule. And in case you forgot, the power-to-power rule simply states that if you raise an exponent to another exponent, like we do here, you keep the base the same and multiply the exponents. Now, with our exponents simplified and our bases the same, we can follow step 3 and set exponents of both of the bases equal to each other. Just like in problem 1, we now have a linear equation. This means we can simply subtract 40 from both sides, which leaves us with 15x equals negative 30. Then we divide negative 30 by 15 to get x alone. And that leaves us with negative 2. Problem 3. Fractions. Some people's favorite, not my cup of tea, but of course it's not too bad. Step 1. Obtain like bases like we have before. This is a little bit different though, because fractions. Do this by rewriting 1 over 27 and 9. First, rewrite 27 in the denominator. This gets you to 1 over 3 to the third is equal to 3 to the power of 2, of course with the other exponents. This gets you to 1 over 3 to the third to the power of 2x equals 3 to the power of 2 to the power of 6x. Now both terms have a base of 3, but as you can tell, the 3 to the power of third is in the denominator and we cannot use it when it's all the way down there. So we have to bring it up and finally apply the negative exponent rule to get rid of the fraction fully. Now with the fraction fully out of the way, we can follow step 2. Finally, it's only step 2. I know, that was a lot for step 1. Follow exponent rules, specifically power to a power rule, like we did in problem 2, to simplify the exponents. Step 3, set both exponents of both bases equal to each other. Step 4, add 6 to both sides of the equation to consolidate x. You could also subtract 12 from both sides. It comes out to be the same thing. Step 5, divide both sides of the equation by 18 to isolate x. And because 18 bits of 0 is still 0, our answer here is a goose egg. 0. And now, the problem you've all been waiting for. Well, probably wanting to avoid. Problem number 4, exponential to logarithmic. Step 1. Since the bases cannot be easily made the same, we are going to rewrite each exponential term into logarithmic form. To convert the terms, set the exponents of the exponential terms as the coefficients of the logarithms, and then set the bases as the arguments. Step 2. Separate x plus 4 log 7 into 2 logarithms, keeping 7 as the argument for both. We are doing this because addition and subtraction in front of log should be separated, unlike multiplication and division. By doing this, we are isolating x into its own log, which will make it easier to move later on. And well, later on is right now. Step 3. Isolate all terms with x onto one side of the equation. Then, step 4, isolate or factor out x from both of the logarithms. Step 5, divide both sides of the equation by everything that are in those parentheses to get x alone. By doing so, we cancel everything in those parentheses that's still attached to the x, leaving x alone on its side of the equation, and we have our pretty big answer. But yes, that is the exact answer. So if somebody wants the exact answer, it's that. But you can also bring it into decimal form, which happens to be around 1.27574, blah, 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 blah. Here are some things to keep in mind, or some takeaways from this video. If you cannot achieve like bases, you will likely have to use logarithms, like we just did in problem 4. When you have a base that is a fraction, you will probably have a negative exponent once you get it all the way where you can use it, and it's not in a fraction anymore. And finally, although we did not do a problem today where that was a problem, remember to simplify the radicals of bases with square roots. And look, we're at the end of the video, and your torture is finally over. Unless you're about to go watch another video on this subject, then this part of your torture is over. But anyway, thank you for watching. Good luck with all the math. And maybe subscribe, stick around, especially if you're doing algebra. I'll be making more videos on that soon. Yeah, I hope you found this video very useful, or at least somewhat useful. And see you next time.